All right, so I thought we'd look at our first linear programming example today. So this one is about room organization, filing cabinets. We've got choices of how many types of filing cabinets for this problem. Just two. I could, of course, have given you tall, medium, and short filing cabinets. I didn't choose to do that because that would be a three-dimensional problem. And all of your applications, I'll just tell you right now, do not have a Z in them. They're all two-dimensional problems, okay? So don't be expecting Z's to pop up anywhere they shouldn't. Okay, so we've got tall and short filing cabinets. We know stuff about how much they cost. We know stuff about how much square footage they take up in our office. We know stuff about how much or how many files they hold, their volume, their capacity. Does that make sense? You guys see that? For each one. We also know about how much money we can spend, our budget. We also know about how much room we have in our office, right? 72 square feet.
So I'm assuming that's the room they have for filing cabinets, not just in total.
If it's in total, that wouldn't really make sense, yeah. Right? Like that's the designated portion of the room for filing cabinets. Great point. Otherwise, we might be stepping on some filing cabinets. I don't think that's going to work. Very good point, Logan. You want to think about your problem a little bit first. See, Logan's in AP Statistics, so he knows about think a little bit, read it a couple times before you start trying to attack the problem. Very smart. But remember, besides constraining equations, we also have this like other thing that we introduced yesterday, like a function that we want to maximize or minimize. What do we want to maximize or minimize this time?
Number of cubic feet that you have for storage.
Yeah, the storage space, cubic feet. Good. In your problems, when you're doing these linear programming questions, you want to make sure that you pick out your function first. Take that out of there before you start looking for your constraints. That's number one important. Otherwise, you're going to have them all mixed together and you're going to be wrong all over the place. So take your function out first. You guys got me? So I've got my space set up for constraints. I probably want to define my variables even before I do my function, though. So if you don't define your variables, you're going to have trouble. So resist my suggestions at your own risk. You do what you want. But what is X and what is Y? We want to clarify that right away so we're nice and clear. What do we have control over combinations of? We have control over space? We have control over money? Do we have like an unlimited budget? No, we have a budget. It's $140 most. No. We have control over what we buy. How many of the short ones? And how you say this is up to you, right? Like it doesn't have to be perfect. It just has to be clear to you. We've got short ones, we've got tall ones. So you can put how many short ones, how many tall ones, the number of short ones, the number of tall ones, whatever makes sense to you. But I'd do it. Otherwise, some of these problems are going to get you. So you're going to be lost on what you have control of right away. Okay. Then I said, pull out your function. We wanted to maximize volume. So I'm going to call it V. You can call it whatever you want. That doesn't matter. So my function that I'm trying to maximize is volume based on the x's and the y's. So V of x, y. Which numbers in here have to do with volume? Only a couple. The short ones have how much space? 8 feet. This guy. The tall ones have how much? 12 cubic feet. So those guys are done now. We've used them, so don't look at them anymore. So how am I going to write that? I don't think it's like rocket science or anything. It's 8 feet for each of the short ones, which were x, plus 12 feet for each of the tall ones, which were y. Okay, there's our function. We're not going to touch that till the end, right? All right, now we look at what we're constrained by. And you want to try to write down what kinds of things are you constrained by? Well, we're constrained by what kinds of things? Price. Be a little more specific, though. I think price, you know, the price works in this case. Price, cost, however you want to say that. Well, I'll go with that. That's fine. Price. So where are our price numbers? Short ones are $10 each, so 10 for each of the x's. Tall ones are $20 each, so 20 for each of the y's. The only other number in there with money this time is $140, so we got to compare that to $140. It said we have it maximum 140, so that way. Remember, my advice, just guess if you're not sure right away. Just guess. That says money we're spending is more than 140. It's got to be like this, right? And equals to. There we go. Okay, that's the price equation. What else are we constrained by? What else are we limited by? The space that we have, square footage, right? So I'm going to put that. I'm going to put square feet. You can put whatever you want, but you should have something there. So square feet, we've got 6 for the short ones. You can cross these all off as you go, right? I'd really recommend that. 6 for the short ones, 8 for the tall ones, and we have at most 72. And then I think there's one more constraint on this situation.
What is many?
Kirsten.
Twice as many shorts as talls.
Now I don't know where that came from, so what you're going to write over here is a personality. It's a judgment personality call, right? Like, who knows where that came from? It's just your personal aesthetic. So how do I write that in an equation? Twice as many shorts as talls. Well, twice as many shorts, talls, which way does it go? Good guess. Is that right? So these are the shorts, these are the talls. Twice of those. I want twice those to be bigger or smaller than the y's? Bigger. Very good. You guys see how I'm doing lots of rephrasing? That's what you've got to try to do too. Okay, so now we've got our equations. We're going to go ahead and graph them. So I'm going to do a little bit of scratch work to get that done. So there's our constraints. I'm going to leave all this stuff, get rid of my scenario. All right, scratch work time. So solving for y on the first one. It's going to be this, right? 140 divided by 20, that goes in nice and even. Isn't that 7? 10 divided by 20 is 1/2, isn't it? There we go. Equation 1. Equation 2 is going to be 8y. Subtract your 6x. Divide by 8. What's 72 divided by 8? 6 divided by 8. It's 3/4. There's our second one. And that one's good to go. You should probably turn it around, though. Don't read things right to left. I don't think any of you guys are Hebrew readers, so not recommended. Okay, graphing time. So we'll sketch these graphs a little bit. 1, 2, 3. 10, 5. I didn't do a very good job, so there we go. So blue guy is here. Down 1/2, something like that. Label your edge. Green guy is here. 1, 2, 3 over 1, 2, 3, 4, something like that. I know the green crosses the blue somewhere, even though my lines are kind of bentish, because why?
Different slopes.
Different slopes, which one's steeper? Green's steeper, because it's 3/4 versus 1/2, right? Okay, so I don't know exactly where they cross, but they should cross somewhere. And my last one I did in black, so let's get that guy in purple. 2x is the easiest line ever, so y-intercept up 2/1, that's going to look like this, right? Label my edges. There we go. So, now we're good to go. We just need to figure out where it's shaded. So we're supposed to be below all of them. It doesn't say below all of them. Below, below, below. Below the green, below the blue, that's down here. Below the purple is over here. It's this triangular thing. Is it really a triangle? No. How many corners does it actually have? 1, 2, 3, 4. There we go. So we've got 4 defined for our table. X, Y. We're going to be plugging into our function, which is 8x plus 12y, in order to get our volumes. First point's super easy, it's the origin, right? Those other points, you can find them however you want. This green guy is the x-intercept, so I know one of the coordinates for this is what? 0. You cannot trust my green line, I bent it. Who knows if it's actually 10? You know for sure that its y value is 0. The y value of the green line is 0, right? So stick 0 into the green line. This is why I'm having you label your edges. So I'm going to do that scratch work right here. 0 equals 9 minus 3/4 x. Solve for x. Very easy algebra problem. Minus 9 minus 9. Times 4 times 4. Divide by -3, divide by -3. What's that going to be? 12. Was my picture perfectly accurate? No, it was not. I wouldn't expect yours to be either. 12 is that corner. Okay. I've still got to find these two. Those are both systems of equations. You can solve them however you want. I'd pick the fastest way that you like. I've got purple versus blue, and I've clearly got those labeled. I've got green versus blue, and I've clearly got those labeled. You can substitute them. You can eliminate them. You can use a matrix equation, or you can solve them with your graphing calculator. I don't care. Since these are all solved for y, substitution is easy. Since they're all solved for y, mx plus b, graphing is easy. I'm going to do one way, one the other. So let's find the green-purple first. Green-purple is 2x is y, so I can stick that into the green. So I've got 2x equals 9 minus 3/4 x. So I'm going to add 3/4, so that's going to be 2.75x equals 9. You guys divide that for me real quick. What's 9 divided by 2.75?
Green, purple, it's green, blue.
Oh, yeah, exactly. Green blue is going to be 2x equals 7 minus 1/2x. So add that, you get 2.5. What's 7 divided by 2.5? Can you guys help me? What is it? 2.8 exactly? Okay, so we've got 2.8. How do you get the y coordinate? Stick it back in. I'd put it in the easy one. What's 2 times 2.8?
5.6.
It's 5.6. Very good. Okay, we've got one last corner to try. If the bell catches us, you guys need to hang in there. Finish this up. You need it. Okay, the last one. I think we're going to go right to the edge. Let's see. So we've got blue versus green. I'm going to do this one with my calculator. Here we go. Y equals, I'm going to do this graphically. You can do them however you want though. So I've got 7 minus 0.5x. Divide minus 3/4. Zoom 6. This should look like the picture I have for the green and the blue. I think it does. Second, calculate intersection. This is something we haven't done for quite a little bit of time. Definitely something you need to know. That's on the left. I should probably have zoomed out, but whatever. That's on the right. It's something like this. 8-3. So now all I've got to do is plug them in. So we've done all the hard work at that point. But the key is to find your corners, you have to solve some systems of equations. I showed you a couple different ways how to do that. So 0, 0 is going to be 0, 0. I don't think that's what we want to do. 12, 0 is going to be 12 times 8, which is 48. This is going to be something, I don't know. 8 times 8 is 64, plus 12 times 3 is 36. That's 100. The question is this one bigger than 100? The answer is no. So, we have our answer. And you guys want to write it out clearly. So, to maximize file space, choose 8 short cabinets and 3 tall ones. You will get 100 cubic feet of space. I don't know how many files fit in that much space. But that's the key. So, just reiterating some of the main points. When you first look through one of those applications, what do you need to pull out first? You guys tell me. The function, the objective function. Yes, you got to pull it out first. And before you even do that, or at the same time, you got to find and define X and Y. Then you think about all the different things: temperature, the cost, the twice thing that we did on this problem, the different kinds of constraints. You graph it, you find the corners by solving systems, and the easy part is the plugging in thing at the end. So it is a large process, so make sure you do your practice, because there's 2 of these on your exam. So see you guys next time.